Okay, so if you are brand new to databases, this lecture is for you. Actually, this lecture is also a good refresher for anyone who has worked with databases for a very long time. It will basically, I'm going to go over everything you ever wanted to know about SQL and how to write SQL statements, and will also help you complete assignment number 3. So by the end of this weekend, you can do assignment number 1, 2, and 3. Number 4 you could probably do as well. It's a comparison between hierarchical and other types of databases. And then number 5 is on normalization. Number 5 you're going to have to wait until next weekend, until another month from now, and if you want to pretty much have an easy time with it. But this will help you get through the assignment number 3. So the assignments for this course are not too bad. They're designed to help you reinforce some of the concepts here. So let's see. SQL. Why SQL? Why not? Everybody likes SQL, right? Now, it's a high-level language. It's not a programming language. You need to use it for almost everything you do with a database. It's usually used from web interfaces, from terminal interfaces, even from little GUIs that you put together. You'll always have a need to write an SQL statement. It's kind of like the equivalence of HTML to web development. SQL to databases is kind of a must. You got to know how to be functional with SQL. So it's a very high-level language. It's not a programming language. It's basically data manipulation language. It makes SQL variable. What makes it variable are the queries that are optimized quite well. So there's many different ways of creating a query. What makes a good query is one that runs faster, an optimized query, which means you're not going to retrieve like select star from the entire thing. You know, your table, you're going to actually only select what you want to select. And I'll talk about query optimization as we go through and make it a little bit more easier. So if this were a classroom environment where I could write on a board as well as project on a board, I'd put these 3 words on the board. And the 3 words I'm going to put on the board are select from where. Every single query has this component in it. So there's 3 principal forms of the query. There's the select, the from, and the where. So the convention of this particular slide set is the keywords are going to be in blue, and they're always going to be capitalized. So SQL is not case sensitive. You don't have to put things in capital letters. However, you will find that most people will capitalize the keywords only because it makes it stand out from the page. And in the other lecture I gave you that said create, and it had table name or create table, that was in capital letters as well, only because it just makes it look a little easier. So this is the basic form of the query. Every query will have a select because you're trying to get something. You can't create a query without a select. You always have a from because you're selecting from a table. You don't necessarily need the where clause. You don't have to put a condition in there. So the select is the desired attributes. Attributes are tables, attributes are columns in tables. And so in the entity relationship diagram we call them attributes. In the table we call them columns. So first name, last name, stuff like that. The from is one or more tables, and you separate the tables by commas. It does not do a join for you. And what it does is it can do a join, and that's a faster join than actually doing a join. But you can select from one or multiple tables, and as we're going to see through the slide set, it comes in handy to be able to use multiple tables. And where is the condition about where the rows are going to be in the table, where everything is less than this, where the first name is equal to that. It's going to be a condition that you're going to put on to further select the rows of the tables that you want to select. So if you memorize that, and if you don't know that already, memorize that. And you'll never go wrong. Those are the 3 components of a query. So let's talk about a few examples related to this. So this is why I like this lecture personally, because it's motivation for drinking beer, actually. Usually my undergrad, first year, or even graduate level, database people can appreciate this example as well, because you guys are of drinking age. So usually by the end of this lecture, I need a beer anyway. So the way this lecture goes is the theme is on beers, bars, and drinking. So it's at least entertaining for the most part. And by the end of the lecture, they'll go, Mary went to the bar and she had a drink. What drink does she want to drink? Bud Light, Michelob Ultra, Coors Light, all these things. Anyway, so all of the queries that we're going to write, that we're going to look at right now, are based on these data set here. And they're all based on the following data scheme, underlining the indicating key attributes. So lo and behold, we have a beers table. Keeps track of beers. Has a name and a manufacturer. Name Bud, Bud Light, manufacturer, Anheuser-Busch. Right, so Coors, I don't know, different manufacturers. Bars, that's where you go to drink the beer. So the bar name, the address, maybe a license number, I don't know. Drinkers, those are the people that go to the bars to drink the beers. So there we have a name, and we have an address, and we have a phone number. Likes, that keeps track of who likes beer, and who goes to the bars, and who drinks the beer. Sells, it keeps track of what the bars are selling, what beer, at what price, and what bar sells what beer at what price. So you can possibly tell, if I were to show you the entity relationship diagram for this, drinkers would probably be a relationship table, and so would sells, probably a relationship table, and even likes could be a relationship table. How do I know that likes is probably a relationship table? Because it has nothing but two keys in it. It has drinkers and beer. So if I were to work backwards on this, beers, probably an entity. Bars, definitely an entity. Drinkers could be an entity, probably is an entity. Drinkers is likes is the link between drinkers and beer. So there's a relationship between the drinkers and the beer that the drinkers like to drink. That's the likes table because we see the two keys in here. And sells, well, is also a relationship because bars sell beer. So we have the bar and the beer. So the bars and the beers can be kept together. And so that we have an attribute associated with the relationship, with the price that they're selling the bar is selling the beer at, is the price, which is an attribute of the relationship. And then frequents, well, that's another relationship. So the dead giveaway in this particular example, if we were to work backwards into an entity relationship diagram, is we have 3 relationships and 3 tables, 3 entities. And it's all represented here in the minimal amount of information needed for the database. We could also, in the future add more to it if we wanted to, but this is pretty much the minimal base that we need. Frequents keeps track of drinkers and also bars. And you notice the names in here, frequents, drinker. We could have just put the word name and everything. How would I know that name was a drinker? And drinker is the name of the table. So sometimes we can make our life easier by naming the key attributes, something associated with, especially if these are 2 foreign keys. Frequents has 2 foreign keys in it. It has the name of the bar and it has the name of the drinker in here. So if we put name comma name, wouldn't have made any sense. But because we put drinker comma bar, bar drinker, it makes more sense. So sometimes it's optional what you name things, but sometimes that helps. So let's start with our first example. So using the beers table, beers has manufacturer and name in it. What beers are made by Anheuser-Busch? So I like to put things on 3 different lines where it says select from where on 3 different lines. It can actually be put on all in 1 line. You are required to put a semicolon at the end of the statement in Oracle. Some databases with the SQL window, it doesn't really matter. Sometimes it will accept a semicolon, sometimes it won't. It doesn't really matter. Oracle requires it, so. What are we selecting? We're selecting name, and name is from beers. So beers is the name of the table that we're looking at here. This is the beers table. So we put the beers table here, and then we're selecting name, and name is an attribute inside of the beers table. So we don't have to select manufacturer as well. But we're going to say where manufacturer, which is the second column, equals Anheuser-Busch, and we're using a single quote here to say that this is going to be what we're equaling to. And this is case sensitive. So if we put it all in caps, it's not going to ever match unless it's all in caps in the database. So that's why some people go like to a 2 upper or a uppercase, lowercase. They start switching the cases around so that when you do the match, you actually get a true match. So it depends on how you have the things stored in the database, actually, and how you're going to search on it. We got too much noise going on in the back. The other thing you might also do and consider is that if you do this on 3 different lines with select from where, I actually start from the from. So if you write, like a blank piece of paper, you pull out a blank piece of paper and you write select from where on 3 different lines. Then you can start anywhere you want. I usually go, well, what table am I working with? I'm working with the beers table. So I put that in first. And what do I want? I want manufacturers equal to Anheuser-Busch. And then, what is it that I really want out of the table? The name, the beers. So then put the beers. So you could do this in any order that you want if you divide it out. If you're writing in a sentence, it's hard to fill in the blanks. And the sentence is like all in one line. So that's another reason why I do it that way. What do I get as a result? I get a result set that looks like this. It has a name, and the name has Bud, Bud Light, and Michelob. Because those are the 3 beers that Anheuser-Busch is producing that's in the beers table. Stop me if I'm going too fast. For brand new people, it might be a little fast pace. For existing people, I'm trying to keep you entertained. And I say existing, I mean people that have a SQL background already. So the answer to this relation is a single attribute, name, and a row with the name of each beer by Anheuser-Busch, such as Bud, Bud Light. I guess I could put Michelob Ultra in here, but Michelob is Anheuser-Busch product. So the meaning of the single relation query, and this is a single relation query because on the from clause, I'm only querying one relation, single. You begin with the relation in the from clause. That's why I always put the from clause first. You apply the selection indicated in the where clause, which is really the second component that you're looking at. And then you apply the extended projection indicated by the select clause. So it really does start with from, goes down to where, and comes back up to select at the end in terms of the algorithm that's actually processing this query. So you can write it in that order if you think in that order. If you don't, you can write it in any order that you want, actually. So what does the language do? Well, to implement the algorithm, which is what I'm talking about here, think about the row variable. So we have a row variable ranging from each row in the relation mentioned in the from. You check if the current row satisfies the where clause. So it's a process of elimination. So it is going through row by row in the query. And if so, you're going to compute the attribute or expression of the select clause using the components in this row. Once it finds the row, it'll start with the from, pick the table, apply the where, find the row. When it finds the row, then it's going to select. So while it's there, it's going to select whatever is in the row, and then the algorithm repeats itself. So if we're indexed, and we're indexed on the primary key, and the where is using the primary key, that's the fastest query you're ever going to see run. Because what will end up happening is on the where clause, it automatically goes to the index first. Finds the index for the matching rows, goes from the index back to the table data where that's stored, pulls out the selected information, and then proceeds back to the index. It doesn't go to the table unless it needs anything, unless it needs something. So does it really matter how many items you select? No, it does not matter. The only thing that happens with the select clause is it makes the result set bigger. You're going to get more than what you asked for. But no query problems at all in the select if you select everything. The only problem is the result set's harder to navigate through. But in terms of efficiency, it runs the same speed. So you don't have to worry about what you're selecting. You can select everything if you wanted to. And if you're going to select everything, you use the asterisk. You could theoretically select each one of the columns you wanted in any order that you wanted, and you get it back in any order. Or you can use the asterisk. So the asterisk here is the select star. So where one relation in the from clause, the star is in the selected, stands for the all attributes in this relation. A lot of people would select star only because they only want to run the query once. So you're going to select star on this particular bank account where the account number, because that's your primary key, is going to be equal to something. You're going to have the fastest running query. You're going to get all the information that comes back. Now it's going to be stored in what's called the cursor. The cursor is the temporary data that comes back from the database. It's actually stored on the database, for which the result set is normally sent to the client from. And then everybody reads and writes to the cursor back and forth. So if you're going to change something you're going to have to run a query to update the database. But in the meantime, you may not have to. If you've selected everything, then you can use it from the cursor perspective and never run that query again. Because in terms of application development, especially from a web perspective, minimize the number of queries that you're running. That's the slowest bottleneck in the entire system. So if you selected star from Beers where manufacturer is equal to Anheuser-Busch, you're going to get this result back, and you only have 2 of them in here. It's no big deal. You have name and manufacturer, but why do I need manufacturer? It's all going to say Anheuser-Busch on it. So again, it's kind of wasted space if you think about it, especially if you're passing this result set back and forth over a network connection. Do we really need a manufacturer in there? Probably not. But now we have everything. We wanted everything. So there's different schools of thought in terms of what you should select. Normally you want to select the minimal that you need, but if you just want to minimize the amount of queries, you select everything. You can also rename attributes here. So if you want a result to have different attribute names, you use an as, and then an as new name to the rename of the attribute. Here's an example of beers from name and manufacturer. So select name as beer. So in this result set, it shows up as name, but we're going to say as beer in here. As beer, comma manufacturer. So we're going to get the beer, comma manufacturer to come out of there on a select clause. From beers where the manufacturer is equal to Anheuser-Busch. Now it says beer instead of name. Why do you want that? Well, because who knows what you called things in the table. And then when the web developer comes back and they're writing this query, they're going to come back and I want the first name, I want the last name, I want this. And they're going to call it something because when they come back in their program, in their script, they're going to take that one and have it equal to something else. So billing address and shipping address, instead of it being B address and S address, they'll just call it billing shipping. And then they can figure out from the result set, well, what is this address? What is that address? And then they can assign it correctly to the local variables in their web form. And it's just a way of tailoring the results so you get it named the way you want it named, because then you can use it quite easily without having to do very much translation to it. So here's beer and manufacturer with the beer being renamed. You can also put expressions in the select clause. And so an expression that makes sense can appear as an element of the select clause. So here we have from cells, and we're going to have bar, beer, and price. That's inside of cells. Select bar, comma, beer, comma, price times 120 as price in yen. Because a couple of minutes after we run this query, we're going to go, what is price times 120? Oh, it's price in yen. Instead of it coming back with price times 120, I'm like, what is that? Okay, and we're doing this from sales, and notice now we don't have a where clause. Don't need a where clause. If we don't have a condition, we can leave the where clause out. Here's the result set. Now it says price in yen. Of course, the numbers, this should be moved over, so it's in 3 different columns. But we have the bar, we have the beer, and now we have price in yen. And the price in yen, we gave it as. So the as renames the column to a different column name or attribute name in the result set only. It does not change the database at all. We can also put a constant expression in the result set. This is very valuable because how do you know what the numbers relate to? We don't know. And you're looking at this result set that came back from this query that the user selected, and you're going to parse the result set, and you don't know what you're looking at unless you put something in there like a little cookie to remind yourself what this query was all about. So here we're going to select drinker, comma, likes Bud as who likes Bud. So drinker likes Bud as who likes Bud. So the column is going to be called who likes Bud, and in the column we're going to put a constant expression. It's going to be called likes Bud. It's going to be from the likes table, and it's going to be where the beer is equal to Bud. So every one of the results that come back from here, we have a column that says who likes Bud, and it says likes Bud, likes Bud. Because how do we know what we put on the where clause 10 minutes later after the after the user has selected the author and the ISBN, the title, it comes back. Normally, if you look at your result set, it says some weird column that says author, and it says the same name all the way down. Because it remembers, oh, that's all from the same author. Because 5 minutes later, I'm going to run the query again. In this case, I'm going to put likes Michelob. And I'm looking at the result set. Now I see Sally, and Fred. Maybe they also like Michelob, who knows. But how do I know that these guys like Bud and the other people that come back like Michelob? I'm not going to know that unless I put a constant expression in here. So I made up a column and I put a constant expression in here to help the user work with the results. So it's nothing more than adding something. And you're not adding anything to the database and not anything to the query either. You're just changing the result set to include likes Bud. And you have this new column, who likes Bud. Simply for the result set. Because some people just print out the result set manually, which actually gives you some more options. Instead of taking the result set and parsing it and loading it up into fields inside of a form or inside of a report, just print it out. It's easier. Just take it in and print it out. When you have a column that says who likes Bud, you can change the name, something else, something more user-friendly. And then you can have the entire query result printed out with not very much processing associated with it. We can also put some complex conditions in the where clause. So from the sales table that has bar, beer, and price, find the price that Joe Bars charges for Bud. So when I say complex, it means more than one in the where clause. So now we're going to select price from cells where bar is equal to Joe's bar and the beer is equal to Bud. Now all we're going to get is price. We're going to get a price that comes out of that. So some important points to note on this particular query. The 2 single quotes inside of a string represent a single quote or an apostrophe. So these are the 2 single quotes here. Joe's bar. Because we put the whole thing in an apostrophe, opening and closing apostrophe, this breaks the apostrophe. Most common people who are programmers who get into this like to put a slash in there. It's no slash, no escape sequence in there. Other databases use a slash because it's more programming like. Oracle doesn't. So it's an apostrophe. Double apostrophe puts in a single apostrophe. It breaks the pattern. It's used as the escape sequence. So the conditions in the where clause can use and, or not. So here we used and I capitalized and because it's a key word here. It doesn't have to be. It can be lowercase. It makes it more readable when it's lowercase, but it doesn't look like a key word when it's lowercase. And then notice all these spaces. It doesn't really matter what kind of spaces you have in there. The spaces are ignored. So the lines actually too. So you can say and or not, and parentheses in the usual way the Boolean expressions are built. And SQL is a case insensitive. In general, upper and lowercase characters are the same except inside the quotation strings, which is in here. So the J in Joe is case sensitive. If it's inside quotes, it's case sensitive. If it's not, it's case insensitive. So just remember that part. We can also do patterns. This comes in handy because what if you don't know what you're looking for? You don't know, but you want to have something that's like something or not like something. So we have the where clause that can have a condition in which the string is compared with a pattern to see if it matches. So here's our general form where we have an attribute like a pattern or an attribute not like a pattern. So the pattern is the quoted strings with this %sign that equals any string, or the single underline that's any character. This comes in handy when searching on telephone numbers, last names, first names, stuff like that. So let's take a look here at telephone number. From drinkers that has name, address, and phone number, find the drinkers with exchange 555, or area code 55. Actually, it's exchange 555. So select name from drinkers, where the phone, and then we have the word like, and then we also have, this is where people leave it out accidentally, still have the quotes because we're still doing a comparison for the equals, where it equals, and it's a single equal, but it's not an equal, so it's just a like. So in the previous example here we have an equals, bar equals, so those people from a programming background think, oh, that's an assignment expression. Yeah, it's a comparison expression. And you know 2 equals. It's just one single equal. You have to get used to that. And here on the likes, this says anything before 555. That's the wild card. Can't use an asterisk, although it would be natural to see an asterisk there. And then the asterisk is everything. Well, it is everything, but in this particular case, you're using that % sign. And then 1, 2, 3, 4. 4 characters. Numbers or characters. Just 4 digits. So you got 4 spaces there. If you put 5 in there, you're never going to find any matches, because nothing is going to be preceded by 5 if it's a U.S. telephone number, which is kind of odd, actually. So where it's like this. So this is anything but 555 in the middle. We also have null values. Have we seen before? If something is not given, we have an empty space in the database. The rows in the SQL query relation have null as a value, and one or more components might be having null. So it means that it depends on the context. So we have 2 common cases. We have missing values, where Joe's bar has some address, but we don't know what it is because nobody put it in, and we didn't put a constraint on their column that said not null. So now it's null. We don't know what it is. Or it might be inapplicable, the value of the attribute for a spouse for an unmarried person. Well, there's no spouse in there. It's unknown. Unless you're going to stick something in there, you're going to get a null that comes out of it. Well, that's what I like in the ITU database. No name, no surname. It's like, okay. Hello, Mr. No Surname. Let's see, comparing nulls to values. So instead of a true or false, now we have a 3 result Boolean logic instead of a 2. We have a true, we have a false, and then we have an unknown. Whenever there's a null, we have an unknown. And the nulls don't get calculated in the true or the false totals. So if you do a count on how many people are in the database and you're counting a field that might have a null in it, your count's going to be wrong. Always wrong. Because it's never going to count any of the null people or any of the empty people. So the logic of the condition in the SQL is a 3-valued logic, true, false, and unknown. Anytime you have a null, you have an unknown. So when any value is compared with null, the truth value is also unknown. So it's unknown. But a query only produces a row in the answer if it's true, where the where clause is true, not false or unknown. So on the trues, we get a count, but on the false, we don't get a count. On the unknown, we don't get a count. So it's not exactly the trues plus the falses equals the whole package. So in the 3-value logic, kind of looks like this to understand how the and, ors, and the not work in the 3-value logic. Think of this. True is equal to 1, false is equal to 0, and unknown is 1/2. Okay, and then and is equal to the minimum, or is equal to the maximum, not x is equal to 1 minus x. It's the opposite of x. So here's some surprising examples here. From this following sales relation, and sales has bar, beer, and price, and it's Joe's bar, and the beer is Bud, and the price is null, because he didn't want to say how much he sells Bud for. It's empty. We're going to select the bar from select bar, which is the attribute we're selecting, from sales, which is this table, where the price is smaller than $2 or the price is larger than $2. Well, it's an unknown or an unknown. We're going to get an unknown out of it. So reason 2-valued laws is equal to 3-valued laws. Well, it's the whole thing is unknown. We're not going to get anything that comes out of it because we have an unknown or an unknown. Unknown. So some common laws, like the commutative property of and, hold a 3-value logic, but others do not. Examples of the law excluded middle, p or not p, which is equal to true. So just know when you have those unknowns, your results are going to vary depending upon the logic because you have 3 components, not 2 to work with. So it's true, false, or unknown. Multiple relation queries, so we can put multiple relations on the from clause and we separate them by commas. We can also query the table on itself, so we can list multiple queries on the same relation and treat the relation twice. So interesting queries from a combining data from more than one table or more than one relation. This is not a join, by the way. This is a multiple query relation. You can address several different relations in the query by listing them on the from clause. And you're distinguishing the attributes from the same name by the relation dot attribute. Here's an example. Using the relation likes, we have drinker and beer, and frequents. Well, we have drinker, drinker again, and bar. Okay, find the beers liked by at least one person who frequents Joe's bar. If we didn't use frequents.drinker and likes.drinker, we would have drinker is equal to drinker. Problem. We don't know which drinker is coming out of which table. So select beer, and then here's our multiple relations from likes comma frequents, where the bar is equal to Joe's bar. We saw that before. And, so we're going to combine this with an and. Frequents dot drinker is equal to likes dot drinker. So we're getting a match. Are we really joining the table? Yeah. It's actually a more expensive join than if we joined the tables. So we have this word join, where we can outer join, inner join, or join, what I'm saying, cross join, different types of joins. The joins are different. The keyword join joins the indexes, and it searches the indexes after the product of the join is produced. Much faster. What's this going to do? It's going to search the likes table index, and it's going to search the frequents table index on everything, more than just the join. So everything in that first table, everything in that second table is searched, and then it's combined on the condition of the drinker equals the drinker. The join is done seconds. This is producing a join theoretically, but it's not using a join. Takes more time because you're searching through multiple tables rather than joining on the index. If you join on the indexed value, which is the primary key, so you take table 1 and table 2, join it on the primary and the foreign key combination, you have the faster running join because you're joining up front, getting rid of all the extra records you don't need. You're only looking at the join condition. You're searching the combination index instead of searching two indexes. You're doing both of them together. Faster join. So just keep that in the back of your mind when we start looking at the joins. That's technically doing a join, but we're not using the keyword join. We're searching two multiple relations. We're searching two relations or multiple relations. So the formal semantics here are almost the same as the single relation semantics queries. You start with the product of all the relations in the from clause. You apply the selection condition from the where clause, and then you project onto the list of the attributes the expression in the select clause. So you could select, here we're just selecting beer. Fortunately for us, beer is only in one table. If it was in more than one table, we could say likes.beer or frequents.beer. We could select one out of either one of the tables. We're using the from both tables, and then the selection on the where clause, the condition on the where clause, excuse me, is the combination of both tables, which is why we're selecting from both tables. If we weren't selecting and using both tables together, then we would have two separate queries. There would be no need to combine them, but we're actually joining the two tables. What does the language do? Imagine one row variable for each relation in the from clause. And these row variables visit each combination of the rows, one from one to the other relation. So each combination from each table is being selected and compared. So if the row variables are pointing to rows that satisfy the where clause, then you send the row clause to the select clause and you select the values that you've indicated. It's an example of sort of what it looks like. We've got both tables. And drinker and bar and drinker and beers over here, the word's wrapped a little bit. It checks over here, compares with this one. If there's a match, then it looks at the select clause. So this picture got a little messed up, so I'll move on from it. Doesn't really matter. So explicit row variables, sometimes a query needs to use two copies of the same relation. So you're going to query the table onto itself. So you got two copies of the same relation. Distinguish the copies from by following the relation name by the name of the row variable in the from clause. We'll see an example of this in a minute. It's always an option to rename the relation this way, even when you're not doing two queries on itself. You can still rename this way. So what am I talking about? Here's a good example. From beers, where we have name and manufacturer, we're going to find all the pairs of beers by the same manufacturer. So we're going to query beers on the beer table. How can we go from beers, comma beers? Not going to work. Or from beers, we only have one table. So this is the key here. So a lot of people will do this just to make it easier to write the rest of the query, which is why I always start with a from clause. So if you start with a from clause, you figure, what do I need to get this from? Well, I'm going to check the beers that match other beers in the same table. Then I'm going to go beers B1, comma beers B2. If I do that, and if I've started with the from clause, then I can come back to the select clause. It doesn't matter that this happened second in the order that this query is being processed, because this always happens first. So we already have which is kind of interesting because they wrote this for people to understand who speak English. You know, select from where makes a logical order for the English speaking people, but it's really from where select. So if I were rewriting SQL as a language, I'd put the from first, because then how am I going to, up here on the select, how am I going to go b1.name? What's b1? I haven't even defined it yet. It doesn't get defined until right here. How's the query going to know about it? It's because query doesn't start at the top. The query starts in the middle. So it's always going to start with a from clause. So if from beers 1 and beers 2, I already have beer 1 defined, I have beer 2 defined, b1 and b2. So up here I can go b1 name, b2 name. And I'm like, what did I just do? Well, I've got the same name out of the same table, but one of them, I've made two copies of the table. I'm going to query B1 with B2. I'm going to find where there's a match between the two, which is why I'm going to be able to query the table onto itself. So where B1 manufacturer is equal to B2 manufacturer, and B1.name is smaller than B2.name, what's that going to do? It's going to order it sequentially, alphabetically. So this less than on alphabet puts in alphabetical order. So I got beer, or I got Anheuser-Busch, Coors underneath it, or whatever. I don't know. It's going to be in ordered. So let's take a look here in the subqueries. Oops. Well, let's take a look at subqueries next. But this here is an interesting combination. So we're going to see this in further examples. A lot of people do this automatically anyway, even though like they're saying beers B1 and drinkers. You go beers B1, comma drinkers D1. You can add, this is called an alias. You can add the alias for the table anytime you want, because it makes this easier rather than putting it. Depends on how long your names are, I guess, as well. So subqueries. We can query a query on a query, or use a subquery. So we'll parenthesize the select from where statement. We can create a subquery, and it can be used as a value in the number of different places, including the from and the where clause. So example, in place of a relation in the from clause, we can place another query and then query its results. So better use of the row variable to name rows of the results. So let's take a look. A subquery that returns one row gives us one result. It gives us an aggregate. So if a subquery is generated to produce one row, then the subquery can be used as a value. So we can use the equals with it. Equals some price. Usually the row has one component, and also typically a single row is guaranteed by the keyness of the attributes. So at runtime the error occurs if there's more than one row that gets produced by the subquery. So let's take a look and see how this works. So from sales, bar, beer, and price, find the bars that serve Miller for the same price Joe charges for Bud. So we have one table here, sells, and we're going to find the bar that sells Miller for the same price that Joe charges for Bud. So there's another bar in there. Joe sells Bud, and if Joe sells Bud, the other bar sells Miller, and we want to know which bar sells it for the same price. So we have two queries would work. We can find the price that Joe charges for Bud, and let's say it's $2, and then we can find all the bars that sell Miller at that same price, $2. That's two queries. Or we could put both of them into one together. So query plus a subquery solution. So here it is. We can select bar from sales where the beer is equal to Miller, and the price is equal to, well, what's the price going to be equal to? Whatever Joe sells Bud for. So select price from sales where the bar is equal to Joe's bar and the beer is equal to Bud. So if we run this subquery first, and imagine this little box is over the subquery. The slide kind of moved it down a little bit, but this will always run first. So the innermost subquery runs first, and then it gets substituted. It's kind of like algebra order. It's the same thing. It's a classic logic order. The inner subquery runs first. The value that results for the equals gets substituted in, and then the outer query gets run second. So the price at which Joe sells Bud is going to be returned, and then the equals is going to be evaluated with the price. And so it's from one table, cells. But we have cells down here too. And we have opening and closing brackets here to tell us that it's a subquery. You have to use the opening and closing brackets. It's kind of like order of precedence. If you don't put the opening and closing brackets in a math problem, it goes left to right. So that tells you go here first. Evaluate whatever's in the bracket first, then substitute that in, evaluate whatever's next. So here we have classic query, just the same as the outside actually. Select price. You have to select just one item in this particular case because you have the equals. So you could actually put average price. You can use a formula with this. Average, sum, minimum, maximum. Put any type of aggregate formula you wanted in there on the price, as long as you get one number back. From cells where the bar is equal to Joe's bar and the beer is equal to Bud. So it's going to come back with $2, and now we're going to select the beer where it equals Miller, and the price is also equal to $2. And it's going to return the bar because we asked for the bar. So it'll come back and return the bar name. That's the equals. If we have more than one item that comes back, we have a set. And if we have a set, we have to go in or not in. Is it in this group or is it not in this group? So that's where the in operator comes into play. So think one value is the equal. Then we have the in operator. This should be an R. This is a row, not a toe. It's a typo. The row in a relation is true if and only if the row is a member of the relation. I mean, it could be in there more than once, but it has to be in there at least once. So the row not in the relation means the exact opposite. It's not in there. So the in expression can appear in the where clauses, and the relation is often a subquery. So you're going to come back with more than one price. So here's an example. From beers, which has name and manufacturer, and likes, which has drinker and beer, find the name and manufacturer of each beer that Fred likes. So Fred likes beer. We need to find the name and the manufacturer of each one of them that he likes. So select star from beers. So here we're going to use the beers table. We don't actually have to list the second table because the second table is already in the query that we're going to run. So where name is in, and here's the key here, is in. Name is in. Well, what are we going to get when we run select beer from likes, where drinker is equal to Fred? If Fred likes more than one beer, we're going to come back with more than one beer because we're selecting beer. So this might say Anheuser-Busch, excuse me, that's the manufacturer. Beer, Bud, Bud Light, Michelob, Amstel, all these beers that come back. The set of beers that Fred likes, and the name is going to be in here. But we're going to select star from beers, which is a different table. All these beers, we're going to select the star from beers where the name is in Fred's list of beers. So if it's in there at least once, it might actually be in there more than once, but if it's in there at least once, there it comes back and it's used. The in and the not in, you just put not in instead of in, and you get the beers that Fred doesn't like. Essentially, you can run the same query and get the opposite. So the set of beers that Fred likes and the set of beers that Fred doesn't like. It's the ones he hasn't liked. The exist operator. So exists in a relation is true and only true if the relation is not empty. The exists means there's something in there. Being a Boolean valued operator, exists can only appear in the where clause. So an example. From beers, which has name and manufacturer, find those beers that are the unique beer by their manufacturer. So the unique beer means it doesn't, it's not in there. So example query with the exists here, we have select name, because we're going to need the name of the beer, from beers B1, where not exist, and then we have our subquery here, and the subquery here is going to say select star from beers where manufacturer, because we're going from beers, is equal to b1.manufacturer, and name doesn't equal b1.name. And then most people look at this and go, well, how come you're using b1 down here, and how does that work? I remember the first thing I said, we always start with the from. We have b1 for us automatically. Because we have beers b1, we have it already. Then we're going to the where's next. The where's has got this subquery, and the subquery's got in the subquery. We have a set of beers that we can take b1.manufacturer and compare it with beers here. But we could say beers. So there's a lot of people that would do this. They'd go beers b2 and then go b2.manufacturer is equal to b1.manufacturer instead of going manufacturer, because this is like, where did this come from? So if you notice, the scope rules manufacturer refers to the closest nested from within the relation having that attribute. This is the next one because we specified it. Kind of leaves you open to default. So there's a lot of people that would actually name the second one B2 and go B2.manufacturer is equal to B1.manufacturer. That's what I would be inclined to do, and it's perfectly acceptable to do it that way. Then there's no guessing. So, and notice here that the SQL not equals operator is being used. This is not equals. So what are we going to get? We're going to set of beers with the same name, same manufacturer name as B1, but not the same beer because not exists. And what are we doing? We're selecting the name from B1 where it's not the same beer. So it doesn't exist in here. And in here we're selecting the beers where the manufacturer B1 is equal to manufacturer B2, and it's not equals, excuse me, the B1 manufacturer equals, we're not getting rid of the duplicates. It's not equal to the same. So name is not equal to the name. So it doesn't exist in there. So it's unique. That's okay in terms of complexity. It's a pretty average query, I should say. When you get past this, you're mostly dealing with subqueries again. More subqueries and more subqueries. But knowing the scope rules is helpful as well. So that's the exist. If it exists, it's in here. If it doesn't not exist, it's not in here. So then we have the any operator. So what about this any? X is equal to any relation is a Boolean condition, meaning that X is equal to at least one row in the relation. Any one of them. Anything. Or not anything. A similarity, the equals can be replaced by any of the comparison operators. So it could be less than or equal to, greater than, anything you want, not equal to. Any of the relational operators can be substituted in for this. Any relation, so X is not smaller than any row in this relation. It's larger than or equal to anything in here. So it's not smaller. Note the rows must have one component only. in this particular case. We also have the all operator, similar to the any. So x doesn't equal all is true if and only if for every row t in the relation x is not equal to t. So meaning all of them in there, x is not equal to all of them. This is true if x is not a member of the relation. And then this operator here, not equal to, can be replaced by any comparison operator as well. Larger than, less than, larger than, less than, equal to. So in this particular case, x is larger than or equal to all means that there's no row larger than x in the relation, because x is larger than or equal to all if it comes back true. Here's an example. From sales, sales has bar, beer, and price. Find the beers sold for the highest price. Okay, so we're going to find the highest price here. If we look at the subquery, we have an all in here, and the all is coming back with select price from sales. So we're going to have $1, $2, $3, $4. We're just going to select, in the subquery we're selecting price from sales, so the price from the outer sales must not be less than any price here. So the price is larger than or equal to all of them. So we're going to return the prices that are larger than or equal to $1, $2, $3, $4, whatever comes out of this group that we're going to get. And we're going to select beer from sales, where the price of that beer is larger than or equal to all of these other ones. So it's an easy way of finding out what are all of these prices. We don't know what the prices are. We do it this way with the subqueries because then we can query the current prices and then query, and we're not fixed with stale data. People that are afraid to do subqueries will do a query. Is the moment you get those query results, because you're going to do 2 queries instead of 1, you got stale data. 2 seconds after you've done the query, you got stale data. So you might as well do the query along with the other query that you're running. Do them both together, then you have fresh data. Because at the same moment, the sales price didn't change. Because it's a dynamic world, the database is actually being used while you're querying it. So what are the chances that a new price are going to be put into the system? Probably not within the 2 seconds, but you do run the risk. So. More SQL. This is normally when I take a break. This is in 3 different sections. Do we need a break? Oh, we're going, yeah, we do. All right, we'll take a short break. This is broken out into 3, so what we're going to look at next is part 2. We just finished part 1, which is basic syntax. If any or all of that does not make any sense to you, during the break you might want to go back through, take a look. Otherwise, you can always download the lecture. This is lecture number 5B, by the way. You can download the lecture and look at it at a slower pace, actually, and you'll probably absorb a little bit more. So let's take a 10-minute break, okay? And, I'll pause the video, pause the capture.